Okay, today's aim is how do we prove a quadrilateral is a parallelogram? So there are a few methods of proving a four-sided figure is actually a parallelogram. Let's review them. This is in 6-3 of the reteaching worksheet that you got. This is in 6-3. So this comes right off of 6-3. It says, is a quadrilateral a parallelogram? And it says there are five ways that you can prove or confirm that a quadrilateral is a parallelogram. The first way is if both pairs of opposite sides are parallel, then your quadrilateral is a parallelogram. Or if both pairs of opposite sides are congruent, then your quadrilateral is a parallelogram. Or, these are all different ways you can prove a four-sided figure is a parallelogram. Or if both pairs of opposite angles are congruent, then your quadrilateral is a parallelogram. Or if you can prove that the diagonals bisect each other, then you can conclude that your quadrilateral is a parallelogram. Or if you can prove that one pair of sides is both congruent and parallel, then your quadrilateral is a parallelogram. There's actually a fifth way, and that is if you can prove that consecutive angles are supplementary, then your quadrilateral is a parallelogram. It doesn't come up very often, so we're not going to focus on that. Let's take an example. Okay, so given angle A is congruent to angle C, angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, prove that ABCD is a parallelogram. As far as we're concerned, ABCD is a four-sided figure. That's it. So what methods do we have to use again? Well, here are the five methods we have to use. And which one am I going to use? Well, if you notice, if you look at the question is telling you that we have a given that angle A is congruent to angle C, right? So I'm talking about angles here. And they're also telling you that angle 1 is congruent to angle 2. So let's mark that. Angle 1 is congruent to angle 2. And they're also telling you that angle 3 is congruent to angle 4. And let's mark that. Angle 3 is congruent to angle 4. Well, since we're talking about angles, which of these am I going to probably focus on? Well, I'm probably going to focus on number 3. I'm going to try to show that both pairs of opposite angles are congruent. Let's see how I'm going to do that. So one of the things I do is I give you a hint here. I said you're going to need the partition postulate, the addition postulate, and substitution to show that angle ADC, this big angle D, is congruent to angle ABC, this big angle B. Okay, how am I going to do that? Well, let's see. If I know that angle 3 and angle 4, the red angles, are congruent, and I know that angle 1 and angle 2 are also congruent, that means if I add angle 1 and 3 together, that will equal angle 4 and angle 2 because of the addition postulate. Equal values added to equal values give you sums that are equal. I also know that angle D is made up of 1 and 3, and I know that angle B is made up of 2 and 4. So therefore, I can conclude that angle B and angle D are congruent. So here's how we're going to do that. So we have our statement, we have our reason. So let's first get the low-hanging fruit, namely angle A is congruent to angle C. So step number 1, angle A is congruent to angle C, and the reason for that, of course, is given. Given. Very nice. Okay, what I'm going to do now is I'm going to say that angle D is made up of angle 1 plus angle 3. So my statement number 2 is angle D is made up of angle 1 plus angle 3. And I'm also going to say that angle B, big angle B, is made up of angle 2 plus angle 4. And the reason for that is because the whole, namely angle D, is made up of the sum of its parts, angle 1 plus angle 3. That's what the partition postulate is. The partition postulate says that the whole is equal to the sum of its parts. Angle D is equal to angle 1 plus angle 3. And angle B is made up of the sum of its parts, namely angle 2 and angle 4. Angle B is equal to angle 2 plus angle 4. So the reason for both of these statements, is the partition postulate. Now, what else can I say? Well, I can say that angle 1 is congruent to angle 2. So let's state that right here. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And angle 3 is congruent to angle 4. Okay, why is that? Well, it is given, right? So let's see what we got. We have angle 1 and angle 2 that are congruent. Angle 1, I'm going to got these in green, and angle 2 that are congruent. And angle 3 and angle 4 are congruent. Let's use blue circles. Angle 3 and angle 4 are congruent. Well, what does that mean? That means that angle 1 plus angle 3 is equal to angle 2 plus angle 4. In other words, angle 1 plus angle 3, angle 1 plus angle 3 is equal to angle 2 plus angle 4. I have two quantities, the greens, that are equal, right? That's 1 and 2. That's right over here. 1 and 2. 1 and 2 are equal, right? 1 and 2 are equal to each other. I'm taking equal values, 1 and 2, and I'm adding to them equal values, namely 3 and 4. So that is the addition property. The addition property says equal values added to equal values, their sums are equal, create equal sums. Now wait a second. We just got through saying that angle 1 plus angle 3, these guys right over here, angle 1 plus angle 3 is nothing more than angle D. So I can say as step number 5 that angle D is equal to angle B, because what I just did is I substituted angle D for 1 plus 3. This is 1 plus 3 here. This is 1 plus 3 here. And the reason is substitution. Substitution. So that's what I have so far. Well, let's take a look. Angle A is equal to angle C. That is given. Angle D is equal to angle B. That is the substitution property, right? So we've got substitution, we've got the addition property, and we've got the partition property. We've used all three. So now the sixth and final statement is ABCD is a parallelogram. ABCD is a parallelogram. Why? Because both pairs of opposite sides, excuse me, not sides, both pairs of opposite angles are congruent. And you are done. Please make sure this is in your notes. Compare this to what you've attempted to do and see what changes you would make to correct your proof.